we have a ball. Just for our understanding purpose, no need of diagram, no need of diagram. There's a ball of mass m, there's a ball. Worst case, take the diagram. Room at 15 degrees Celsius, then this will also have 15 degrees Celsius only because the ball is kept. The heater supplies heat at a constant rate. Okay, the heater is going to supply the constant rate 24 watt at all the instants. So it is going to supply at a constant rate. This much is there. So finally, the temperature ball, as I shown, assume that rate. Finally, it was at 15. Temperature of the ball will become 45. You see this. The temperature of ball rises with this one. So here it is 45 degrees Celsius. This is how much. The room is 15 degrees Celsius. The first initially will write the equation from the Newton's laws of heating formula. What this ball will do, will absorb heat from this and also start radiating. Now what about here? Here what actually happens? It will radiate and it will absorb from the room as well as from heater, no? Okay, this heater I had to okay, it has to go into the ball, no? That is, yeah. Okay, I made changes. We are eating the ball, no? Not the room. No. What actually? It's very simple. It will receive heat from where? From the room as well as from the heater coil. And in turn it will radiate. I'll show few. What is this? This is the heat received. And at the same time it is going to radiate. And it will receive heat from the heater coil also. Look at the arrows. We have arrows here now. So the power received by, because this is at final, this is the final, this is the initial. One problem you understand, I think you can manage. So finally what actually happening is like a power received. Looking at this diagram, power absorbed equal to power emitted. Power absorbed by ball equal to power emitted by ball. I feel like thinking in this way a little bit easier. What is the power absorbed? It is going to absorb from power. So from where? From K into temperature 15 degrees Celsius plus 24 watt. And power emitted by the ball, K into 45 degrees. So this 24, it is in fact in the books we have will show like this. I think this column K, the Newton's laws of heating formula. This you find very difficult. Some of you are finding very difficult. I'm just putting in this way here. So K, what happens? It all depends on sigma, area of cross section, mass, specific heat, emissivity. All parameters will come into picture. What all power it gains from the heater coil. Okay, and what all it gains power from the room, what happen, that is going to radiate because the temperature will remain constant. So how you can write this equation? Because final we are discussing here. Okay, finish out. So now we know the value of K. So K will be 24 by 30. (12 by 15). Now after this, let's come to the, I think problem is not over. Calculate the rate of loss from the ball when it was temperature is 20 degrees Celsius. When temperature of ball is 20. Room temperature will remain 15 only, no? Why it will change? When its temperature was 20 degrees Celsius. So what shall I write now here? Something it is going to lose some power, no? Rate of loss of heat from the ball when its temperature. Loss of heat is telling. Loss of heat means the one which will emit. Shall we write K into 20? The one which will emit, or something loss we have to calculate. I think I have something here. Based on this, I'll take a decision. That's all. Himself is, I highlighted one. I assume that the rate of heat loss from the surface of the ball to surrounding is proportional to temperature difference between the ball and surrounding. He has given that, I'll write it. There's a loss. Yeah, I show then, yeah, right. 20 minus 15 is telling temperature difference between ball and that. That's what the loss is telling. So do we know value of K? We don't know. That's why we took earlier method. You get the answer. That loss is proportional to temperature difference. He has said that. Okay, I'm writing that equation.